Hello, I'm Hanna Kartynnik and I'm going to present my results on the speech recognition course project, Automated Speech Recognition in the Multi-Speaker Environment with a VoiceFilter Model. When the speech of multiple persons and background noise get mixed in the input audio stream, the performance of speech recognition systems tends to degrade considerably compared to the scenario of clean single-speaker audio. This setup has been famously named the cocktail party problem. One approach to the problem proposed in the VoiceFilter paper assumes that we have a reference audio with clean voice of one of the participants from elsewhere. In the case of speech assistants, this can be a personal voice enrollment process. The idea is to learn how to mask noisy audio features to attend to this particular speaker only. I started with data preparation. First, I've written an algorithm for extracting clean audio segments where only one speaker talks using the data in the transcripts and applied it to the AMI dataset. Second, I randomly selected an audio segment of sufficient length for each speaker to be the reference recording for the speaker embeddings. Next, I combined the rest of the segments for every speaker and split them into 3-second chunks. Finally, by summing the clean audio with weighted interfering audio, I mixed the obtained chunks with randomly selected speakers from the AMI dataset and different types of audio noise from the Musan corpus of music, speech, and noise. Another half of the dataset is comprised of clean samples which shouldn't be affected. As a result, I've prepared a training set with about 285 hours of mixed audio samples. For the architecture of the VoiceFilter model, I used a configuration similar to the one provided in the original paper. It takes acoustic features and a speaker embedding as an input and predicts mask to separate the target speaker. Basically, the model consists of several 2D CNN layers, a bidirectional LSTM layer, and 2 fully connected layers. I also used the pre-trained VoxLab model to obtain target speaker X vectors. The model was formulated and trained in the Caldi Net3 framework. I performed several experiments, however, since they are very expensive, I haven't been able to change all the parameters independently. The variations were in the following characteristics: the size of the training dataset, whether X vectors were used directly or reduced via PCA, model architecture, the number of specific layers and their dimensionality, various input-output audio features, as I was aiming for a drop-in replacement in the original AMI recipe that uses MFCC features. For filter banks, I implemented a filter bank to MFCC conversion binary. After training my VoiceFilter model, I obtained masked filter bank features for development and evaluation sets of the AMI dataset, and used them in the best existing recipe for this dataset. In the table, you can see the baseline word error rate for the original recipe I trained separately, as well as the best word error rate across my experiments with VoiceFilter. As of yet, I wasn't able to improve upon the baseline, however, I'm still exploring the parameter space. Thank you for your attention.